Find the time period of the oscillation of mass m in figure ABC. What is the equivalent spring constant of the pair of spring in each case? Fine. Now let's say if I talk about A part, this K1 and K2 are in parallel. Right now I'll give you a concept that if the two springs are in series, then K net for the series combination will be given by the equivalent resistance of the parallel combination of the resistances. For say if K1 and K2 are in parallel, if K1 and K2 are in series, for say that is in the C part, okay, then K net will be given by 1 by K1 plus 1 by K2. This is the resultant of the two springs that are in series, and if the two springs are in parallel, this is of the series, and if the two springs are in parallel combination, then the net K spring constant will be equal to K1 plus K2. Fine. Now I can solve the theory of the part very easily. In A part, the two springs K1 and K2 are in parallel combination, so K net will be equal to K1 plus K2, and the time period will be equal to 2 pi under root of m by K net, that is K1 plus K2. In B part, this equation, this figure can be easily modified. You know why? Because this K1 and K2 are again in parallel. What I can do is I will disjoint the spring from over here and connect it at this very position. So my figure will become like a spring like this, another spring like this, and a mass m, K1, K2. This can be done when such a kind of figure is there. So K1 and K2 are again in parallel, so time period will be again 2 pi under root of m by K1 plus K2. In C part, K1 and K2 are in series, so K net will be equal to K1 K2 divided by K1 plus K2. So time period will be equal to 2 pi under root of m by K net, that is K1 K2 to K1 plus K2. That is the answer.